Hello, everyone. I hope you're all healthy and well. Welcome to the next talk in our Golden Webinars in Astrophysics series. Our speaker today is Avi Loeb, who is the Frank B. Baird Jr. Professor of Science at Harvard University. My name is Thomas Puzia, and together with Demetra De Chico, we have organized today's webinar for you. As in our previous webinars, we have again arranged for simultaneous language interpretation, which will be provided by Patricia Gonzalez, who will be simultaneously translating for us into Spanish. En sus dispositivos pueden escuchar la interpretación al español de la conferencia al pinchar el botón de interpretación que se encuentra en la parte inferior derecha de la ventana de la aplicación Zoom y seleccionar español. We would like to acknowledge the generous support of the Center for Astrophysics and Related Technologies, also known as CATA, for its Spanish acronym, for making this series possible.
Thank you so much for all your feedback and comments. If you're watching a recording of this talk on YouTube, please leave your comments below. If you would like to support the Golden Webinar series or give us feedback, please send us an email. If you have any questions during the talk, please type them in the Q&A window. You can also upvote questions and comment on them. We will select the best questions for the discussion after the talk. Before we begin, I would like to briefly introduce our other panel members that are with us today. Of course, we have our speaker, Avi Loeb, and our interpreter, Patricia Gonzalez. We have Thomas Puzia, as usual, and myself. And then from the faculty at the Institute of Astrophysics at PUC, we have Felipe Barrientos, who is director of the Institute, and also our postdocs, Elizabeth Arthur de la Villarmont, Paola Ronco, and Giuseppe Dago. We also have the great pleasure to welcome our guest panelists today. Sarah Seeger, class of 1941 professor of planetary science, physics, and aerospace engineering at the Massachusetts Institute of Technology. Jill Tarter, chair emeritus for SETI research at the SETI Institute. John Blakeslee, director for the science at Gemini Observatory. Paul Heunigen-Hühne, professor of philosophy in Institute of Philosophy at the Leibniz University, Hanover, Germany, and lecturer at the Department of Economics at Universität Zurich. Stephen Beckwith, professor of astronomy and director of the Space Sciences Laboratory at the University of California, Berkeley, ex-director of the Space Telescope Science Institute. Dietrich Bade, astronomer at the European Southern Observatory in Garching. And last but not least, we have our excellent Q&A manager, Ricardo Acevedo.
So it is our great pleasure to introduce Avi Loeb as our Golden Webinar speaker today. Avi has obtained his PhD degree in physics at Hebrew University of Jerusalem at the age of 24. From 1983 to 1988, he led the first international project supported by the Strategic Defense Initiative, then was a long-term member of the Institute for Advanced Studies at Princeton for the next 5 years. He was then assistant professor at the astronomy department of Harvard University, then associate professor there, and became full professor in 1997. He has been director of the Institute for Theory and Computation since 1997, and also founding director of the Black Hole Initiative since 2016, both at Harvard University. He has served as chair of the Board on Physics and Astronomy of the National Academy since 2018, and is an elected fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. He is a former member of the President's Council of Advisors on Science and Technology at the White House, and member of the advisory board for Einstein Visualize the Impossible of Hebrew University.
Since 2016, he has also chaired the advisory committee for the Breakthrough Starshot Initiative, and has served as the Science Theory Director for all initiatives of the Breakthrough Prize Foundation. Avi wrote 8 books and over 800 papers on a wide range of topics, including black holes, the first stars in the universe, gravitational lensing by planets, and the search for extraterrestrial life and the future of the universe. In 2012, Time magazine selected him as one of the 25 most influential people in space, and in 2020, he ranked among the 14 most inspiring Israelis of the last decade. In 2017, he hypothesized that radio emission of artificial origin could be detected from Oumuamua, the first known interstellar object detected passing through the solar system. So we now hand it over to Avi, who will tell us about extraterrestrial life. Are we the sharpest cookies in the jar?
Thank you so much. Just wanted to make 2 comments while I'm sharing my screen. First of all the labels that you heard about me are not really important. Basically, you can regard me as a farm boy. I was born on a farm, and I'm pursuing science as a continuation of my childhood curiosity. So these labels came along the way, but they are not important. What matters the most is I follow the evidence and I try to figure out what the world is like. The second comment I wanted to make is that half of my genetic making, DNA, is Spanish. And I'm very proud to be speaking to a Spanish audience. I'm sorry that I cannot give this talk in Spanish, otherwise I would do so. So it's a great pleasure to speak with all of you. And I will be discussing my new book that just came about 10 days ago, came out, was published, and is receiving an extraordinary amount of attention, much more than I expected. Just to give you a sense, my literary agent told me a month and a half ago that I should eat a healthy breakfast before I meet with Joe Rogan, because the interview will take 3 hours. Little did she know that for 6 weeks, I would have back-to-back interviews from 8 a.m. till 8 p.m. So instead of a marathon of 3 hours, it was actually a marathon of 6 weeks, and was really quite exhausting, but I thought that it's an important platform for me to communicate the excitement we have as scientists. And if I had to summarize my book, Extraterrestrial, I would use the sentence, when you are not ready to find exceptional things, you will never discover them. And that has been the subject of a Scientific American essay that I wrote a few months ago. What you see on the left is a photograph of a photograph that was put on exhibit in Berlin just a few months ago by the famous photographer Herlinde Quilbel. And she asked me to write on the palm of my hand the most important question that I can think of in the context of science. And my question was simple: are we alone? And just to explain where I come from, I wanted to read an excerpt that illustrates why I believe that modesty is really important. And that's the biggest lesson I've learned from several decades of practicing research in astronomy. It's really the message we get from the sky, that we should be modest. And, you know, it's not obvious. In fact, most people are not modest, starting with the ancient Greek philosopher Aristotle, who argued that we are at the center of the universe. And that was flattering to the ego of many people. And for 1,000 years, everyone adopted this notion that we are at the center of the universe. You know, it's very comfortable to believe that we are important, special, and unique. But I will try to advocate throughout this talk that it's actually the wrong attitude. And so let me read from my book a couple of paragraphs. My father, David, was laid to rest in the same red soil in which he planted trees all of his life, in the vicinity of those plantations that he watered routinely, near the house that he built with his rugged hands and that I grew up in, surrounded by the people he loved and who loved him in return, under the blue sky that I study as an astronomer. My mother, Sarah, who put me on the road to thinking as a philosopher, with whom I spoke daily throughout my adulthood, and who especially gifted me with the life of the mind, was buried beside him 2 years later. In astronomy, we realize that matter takes new forms over time. The matter we are made of was produced in the hearts of massive stars that exploded. It assembled to make the Earth that nourishes plants that feed our bodies. What are we then, if not just fleeting shapes taken by a few specks of material for a brief moment in cosmic history on the surface of one planet out of so many? We are insignificant, not just because the cosmos is so vast, but also because we ourselves are so tiny. Each of us is merely a transient structure that comes and goes, recorded in the minds of other transient structures. And that is all. And I'm really surprised by the fact that so many arrogant people lived on Earth. How could they be arrogant? How could they think highly of themselves? These were usually alpha males, like the one portrayed in this picture, kings and emperors that conquered a piece of land on Earth and felt very proud of themselves. I mean, we have some around us today as well. But the truth is, there are more habitable Earths in the observable volume of the universe than there are grains of sand on all beaches on Earth. There are of order 10 to the power 20 zeta Earths in the observable volume of the universe, and there might be many more outside of where we can see. And that's because a substantial fraction of order a half of all sun-like stars host an Earth-sized planet roughly at the same separation as the Earth is from the sun. We know that from the latest Kepler satellite data. And if that's the case, all these billions of planets in the Milky Way galaxy could have liquid water on their surface and the chemistry of life as we know it. If you arrange for similar circumstances, the most commonsensical view would be to say, you get similar outcomes. Therefore, it should be mainstream in astronomy to assume that we are not alone and to search for others. But instead, I'm really struck by the fact that the mainstream community asks for extraordinary evidence that we are not alone. In other words, the default is that we are special and unique. And what I'm trying to advocate here is a sense of cosmic modesty. You know, this is the one message that we get from the sky. And, you know, those kings and emperors that conquered a piece of land here on Earth and felt very proud of themselves resemble an ant that hugs a single grain of sand on the landscape of a huge beach. It's completely ridiculous. But I can understand where it comes from. When I watched my daughters when they were young, they tended to think that they are special and unique and they are the smartest because they were at home. But as soon as they went to the kindergarten, they met other kids, that some of which are smarter than they are, and they got a different perspective. So the only way for our civilization to mature is by getting evidence about others in our neighborhood. And of course, we will never find out if we don't search. So right now, the mainstream scientific community in astronomy is asking for extraordinary evidence before even discussing the possibility that there are others on our street. And that's exactly opposite to where it should be. And it's sort of like a self-fulfilling prophecy, because if the funding for the search of technological signatures is 1,000 times less than the funding in the search of the nature of dark matter. You know, we invested hundreds of millions of dollars in searching for dark matter, weakly interacting massive particles, axions, ideas that were proposed and were ruled out over the past few decades. So why is it that we invest 1,000 times less in the search for technological signatures? That makes no sense, because, you know, if we replicate the conditions on Earth on so many other planets, it should be mainstream to consider their signatures. And who cares what the dark matter is? It will not have much effect on our daily life. I mean, of course, academically, it's interesting. But if we find a smarter kid on the block, that would have fundamental implications for our society. So how is it possible that a subject so important and so interesting to the general public, and by the way, the general public funds science. So how is it possible that the scientific community will avoid discussing it, ridicule anyone that is discussing technological signatures or an interpretation associated with technological civilization, ridiculing it on Twitter and making fun of it and bullying anyone that works on this subject? It, you know, the biggest effect is on the younger people, because they see that reaction, and as a result, they decide not to work on this subject. So you don't have fresh talent entering this search. And then when the funding is down at the factor of 1,000 relative to dark matter search, you don't have much work done. And then, of course, it's just like stepping on the grass and saying, look, the grass doesn't grow. Bring me extraordinary evidence, but I will not give you funding to find it. I will bully anyone that works on it, so the young talent will never go there. By the way, the young talent goes to work on extra dimensions, string theory, the multiverse. These are mainstream topics. How is that possible that subjects that have no connection to experimental verification are getting support from the mainstream? My only interpretation is they are used as sandbox to demonstrate that the practitioners are smart. So if a large enough community of people in the academic culture decides that you can work on some mathematical arena and demonstrate that you are smart and therefore get awards, and without putting any skin in the game, without testing it against experimental evidence, then that's completely fine. But if you're talking about looking for evidence for something that might as well be out there, that's ridiculed. Something is really wrong in the current scientific culture. And my book is attempting to correct that. Now, we are probably not the sharpest cookies in the jar. And by the jar, I mean the Milky Way galaxy. For a variety of reasons. You know, what's the chance that if you start from the chemical soup that existed on Earth, the soup of chemicals, you end up with the smartest possible species? I mean, it's just like looking at recipe books, you know, and you can start from the same ingredients, get very different cakes, depending on how you mix them. And I find it hard to believe that out of random processes, Earth ended up baking the best cake. But moreover, if I watch the news every day, it doesn't look like we are very intelligent. We're wasting a lot of resources on fighting each other rather than working together towards a better future. Just take the example of racism. I mean, that makes zero sense, that by the color of a skin, you would decide what the qualities of a person are. I mean, if you look at the big picture, you know, we are all the same relative to the rest of the universe. And so perhaps we are not that intelligent if we behave the way we do. And we might learn something by finding others out there. Maybe there is a smarter kid on the block that we can learn from. That's my hope. I mean, I do not find a lot of intelligence here on Earth, and that's part of the reason why I look up into the sky. Perhaps it's there. Now, we know that Earth is our home, but it will only be so for a while. There are internal threats as a result of climate change, non-conventional wars, pandemics, political or technological catastrophes that we bring on ourselves, like self-inflicted wounds. And obviously, the technologies we develop could also bring to our own destruction. That may imply that other civilizations are short-lived. Perhaps they don't live for more than a few centuries, because typically you find yourself roughly in the middle of your life, statistically speaking. So perhaps we developed technology for a century. We have a few more centuries to go, and that's it. But there are also external threats. For example, 66 million years ago, there was a giant rock, roughly the length of Manhattan Island, that approached Earth. The dinosaurs looked up. It must have been an amazing sight to see this rock getting bigger and bigger on the sky, but the fun stopped when it hit the ground. Now, the dinosaurs had huge bodies. You might think that's very useful for survival. Turns out that even though the human body is much smaller, the brain is really important for survival, because we can have astronomers looking at the sky and searching for rocks that may hit us. And then if we identify any dangerous rock, we might attempt to deflect it. That was the basis for the task that the Congress gave to NASA to identify all objects bigger than 140 meters, or maybe not all, but 90%, more than 90% of all objects bigger than 140 meters that arrive close to Earth. These are called near-Earth objects. And the first attempt in this direction came with the Pan-STARRS telescope on Mount Haleakala in Hawaii. And in less than 3 years, the Vera Rubin Observatory in Chile will attempt to continue that task and identify about 60% of all these objects. So about 2/3 of the congressional task. Of course, 140 meters is a much smaller size, about 1% of the size of the rock that killed the dinosaurs. But I should say that there are other risks, and of course, within 1 billion years, the sun will boil off all the oceans on Earth as a result of a greenhouse effect. So we will have to move into space. And other civilizations may have done so already, because keep in mind that the sun is a relatively late comer. It's most of the stars in the universe formed before the sun, billions of years before the sun. So if they follow the similar history, then there were lots of civilizations that predated us billions of years ago. And so most of them are dead by now. We can search for their relics. You know, we can't have a phone conversation with the Mayan culture, but we can have an archaeological dig that will find traces of the Mayan culture. So the same thing in space. We can have space archaeology, search for relics of those civilizations that existed before us. They will be floating in space. And that's to replace the approach we were using over the past 70 years or so to look for radio signals, because radio signals are just like having a phone conversation. You need the counterpart to be alive, and that narrows down the number of possibilities dramatically. There are many more dead civilizations than live civilizations. So I suggest, instead of looking for signals, let's search for relics. Now, let me say a few words about my personal history. I describe it in my book as well. I was born on a farm. I used to collect eggs every afternoon, as you can see in the second image from the left. And I used to drive the tractor, as you can see in the third image. There I'm sitting next to my sister. I used to drive this tractor to the hills of the village or on weekends and read the philosophy books, because philosophy addresses the most fundamental questions we have. And unfortunately, it doesn't answer many of them, but that was the love of my youth. I mean, I really wanted to become a philosopher, but the circumstances prevented me from doing that, because in Israel, where I was born, there is obligatory military service at age 18. And I was drafted into a program that allowed me to pursue a PhD in physics for the benefit of the defense of the country. And I prefer that over running in the fields with a gun attached to me. And so it was closer to philosophy, but not really philosophy. And then I led a project that was the first international project funded by the Star Wars initiative of President Ronald Reagan. And that brought me to Washington, D.C. quite frequently. And in one of the visits, I visited the Institute for Advanced Study at Princeton, where I was offered a 5-year fellowship under one condition, that I'll switch to astrophysics. Now, I didn't know how the sun shines. It took me several years at Princeton to actually learn the vocabulary. But that was actually a benefit for me because nobody told me what to research, and I had to sort of invent myself in this new area of research. And I became independent, and I thought about defining my own problems, so to speak. And then I got to Harvard because nobody wanted that kind of a position. The chance of getting tenure were quite small, and I didn't worry about it so much because I always had plan B of going back to the farm. And I still have that in mind when my colleagues are irritating me. Anyway, I met my wife, Ofrit, and you can see it on the right. I have 2 daughters, so altogether I'm surrounded by 3 women, which is the greatest blessing of my life. And then in 2015, as you can see at the bottom left, a black limousine parked in front of the Center for Astrophysics at Harvard. And out of it came an entrepreneur from Silicon Valley, Yuri Milner, entered my office, sat on the sofa in front of me and said, "Would you be interested in leading a project to visit the nearest star within our lifetime?" Now, Yuri and me are both 59 years old, and what it meant is really 20 years. And I remember that the nearest star is 4 light years away. So it takes 4 years for light to travel the distance. You need a spacecraft that travels at 1/5 of the speed of light. Is that possible? I told Yuri that I need about 6 months to think it over, and then I'll get back to him with a recommendation. And together with my students and postdocs, we looked at various possibilities and concluded that there is only one technology that can accomplish this task. And that's a light sail being pushed by a very powerful laser beam. And I'll talk about it in a minute. We announced it in April 2016, and Stephen Hawking came for the announcement, the public announcement in New York City. So here is a picture of the solar system. The sun is on the left. And then you can see the planets. At roughly 10 times the Earth-Sun separation, you find Saturn. And at 100 times the Earth-Sun separation, you find the heliopause, also the Kuiper belt. Now, the heliopause is the place where the solar wind is stopped by the interstellar medium, the gas that fills in the void between stars. But the solar system doesn't end there. It actually extends to 100,000 times the Earth-Sun separation. So 1,000 times farther than the heliopause. It's a huge volume. And most of it is occupied by the so-called Oort cloud that contains the Lego building blocks of planets. So these are rocks, most of them covered with ice, that were left over from the construction project of the solar system. So the planets were made out of small building blocks, and some of them got scattered into the Oort cloud. And when these icy rocks get close to the sun, some of them, they warm up and they appear as comets. And actually on Monday, I'll give you a scoop. On Monday, you will hear about a Nature paper that we have that talks about the fact that the dinosaurs were most likely killed by the disruption of a long period comet that disintegrated near the sun. So for the details, check out the news on Monday. Now, the Oort cloud is roughly halfway to the nearest star, Proxima Centauri, which is a member of a 3-star system, Alpha Centauri. And that means that if those stars have also an Oort cloud, the Oort clouds are touching each other, just like densely packed billiard balls. So think about interstellar spaces filled with Oort clouds touching each other. So when stars pass near each other, the most loosely bound objects at the periphery of the Oort cloud of each star could easily get ripped apart and become members of the population of interstellar objects, objects that do not belong to any star, but just move through interstellar space. And we actually calculated the expected population of interstellar objects with Ed Turner and Amaya Morrow-Martin. In 2007, that was the first paper written on this subject. And we forecasted that the Pan-STARRS survey telescope will not find any. The number was off by a factor between 100 and 100 million. Many orders of magnitude less than necessary for Pan-STARRS to find anything. But we said that with the Vera Rubin Observatory, we might find some. Now, Proxima Centauri, which is illustrated here, has a planet in the habitable zone. This is a star that is only 12% of the mass of the sun. It's a dwarf star. It has roughly half the surface temperature of the sun, 3,000 degrees. So instead of the sun emitting visible light, this star emits infrared light. We have eyes that are sensitive to visible light because that's helpful. This light is very abundant here on Earth, coming from the sun. And when it bounces off objects like predators, it helps you to survive. You can run away from them if you detect that light. So that's why our eyes detect visible light. But think about creatures that might exist on the planet next to Proxima Centauri, the habitable planet. They should have infrared eyes. And by the way, most of the stars in the Milky Way galaxy are dwarf stars like Proxima Centauri that live 1,000 times longer than the sun, up to that. So most of the creatures in the Milky Way galaxy might have infrared eyes. Maybe that explains why interstellar tourist agencies never advertise vacation sites on Earth, because these creatures do not like green grass. They are used to dark red grass in their home planets, and the visible light hurts their eyes. So why would they ever come to visit us? The only way for us to get their attention is perhaps go there and entice them to visit us by offering them a water-based drink. Now think about the planet next to Proxima Centauri. It's so close, it's 20 times closer than the Earth is from the sun. That's why it's habitable, even though the star is so faint. And it's so close to the star that it's tidally locked. It shows the same side to the star as it moves around. And by the way, it finishes a circle in 11 days. So if there are any creatures there, they celebrate their birthday every 11 days. There must be a lot of parties over there. But there is a permanent day side and a permanent night side. So the creatures on the night side would be very different than those on the day side. And there is a permanent sunset strip that separates the two sides. My daughters say that the real estate value of that strip will be very high because you can see the sunset forever. So if we ever go there, they want to have a house in the permanent sunset strip. Now, we might want to go there to see what's going on, to see all these parties. And if we want to do it in a couple of decades within our lifetime, we need a spacecraft that travels at a fifth of the speed of light. So the concept we proposed to Yuri Milner was to have a light sail pushed by a very powerful laser beam. What you need is 100 gigawatt focused on a sail roughly the height of a person, few meters, that weighs of order 1 gram. And one can show that this would push the sail to a fifth of the speed of light within a few minutes. And the distance over which the sail will travel during that time is 5 times the distance to the moon. And of course, you can equip the sail with miniaturized electronics, the kind that you find in a cell phone, that includes a camera, navigation device, communication device, as you can see in the middle panel. The approach of a light sail was already tested using the light from the sun. What you see on the right side is the Light Sail 2 deployed by the Planetary Society in 2019. And here is the concept. A lot of small, low-power lasers combine their beams to a very powerful laser beam. You need a coherent beam of radiation so you can focus it on a few meters over the distance of the launch. Of course, the sail is released by a mother spaceship above the atmosphere so that it doesn't feel the friction with the atmosphere. And one can release a sail every day. And then within a few minutes of shining the laser on the sail, it will reach a fifth of the speed of light and then travel for 20 years. So a few minutes for launch and 20 years for the journey, which is quite boring if you think about it. But then eventually the sail will get to the Proxima Centauri system, hopefully pass close to the planet and take a photograph. And the biggest challenge is to transmit this photograph so that we can receive the information back on Earth. The beam of radiation that will relay this photograph to Earth will spread most likely across a distance larger than the Earth-Sun separation. So it would be very faint when it arrives to Earth, but with a large enough telescope, we can receive the signal. This is the starshot concept, and we are currently working on developing the necessary technologies. But as far as I'm concerned, it's not so much whether there is primitive life on either Mars or the nearest star system. It's more about, are we the smartest kid on the block? And as I mentioned, there is no good reason to expect that. Perhaps that's why many of my colleagues are not willing to engage in the search. Just like my daughters, if I were to ask them, they would prefer not to go to the kindergarten, because then they can keep the illusion that they are the smartest. But my suggestion is that without a prejudice, we should do the search, that knowledge is always beneficial. You want to know who lives in your neighborhood. I don't want to bury my head in the sand, just like those philosophers in the days of Galileo that said, no, we don't want to look through a telescope. We know that the sun moves around the Earth. And they put him in house arrest. Now, that simply maintained their ignorance. But it didn't change the fact that the Earth moves around the sun. Reality doesn't really care about whether you ignore it. And we can be ignorant. That's perfectly fine. I mean, animals do not care about the large environment that surrounds them. They don't need scientific knowledge. They just live their life. And we can do that as well. But for me, knowing is the greatest pleasure you can have in life. And that's why I do my science. I don't care how many likes I have on Twitter. Just like basketball coaches, I keep my eyes on the ball, not on the audience. And frankly, I don't give a damn about what other people say. And if the evidence is exciting and interesting, I follow it. Just to give you an example, in the context of the object that I'll describe in a minute, there was a seminar at Harvard. The name of the object is Oumuamua, and I'll get to it in a minute. And when the seminar was over, I left the seminar room with a colleague of mine that worked on rocks in the solar system for decades. And he said, Oumuamua is so weird, I wish it never existed. That was appalling to me, because the biggest thrill you can have as a scientist is to find evidence that doesn't quite line up with what you expected, because you learn something new. Obviously, it takes you out of your comfort zone. But if you think about quantum mechanics, it took a lot of people out of their comfort zone. And Einstein resisted spooky action at a distance until his death. And then experiments verified that Einstein was wrong. So who cares if it takes people out of their comfort zone? What matters is what reality is about. And that's what we have an obligation as physicists to find out. It's not about being liked on Twitter. It's about finding out what reality is. It's not about honors, awards belonging to honorary societies. So let's be open-minded. And by the way, I'm really struck by the fact that the commercial sector is often more open-minded than the academic community. And one way to interpret that is the academic community right now is driven by the desire to build an image such that you optimize your chances to get awards and honors, and you go along a path that satisfies the wills of the selection committee for those honors, rather than taking risks and putting some skin in the game. You know, kids literally put skin in the game. That's why they get bruised all the time. And I want to maintain my childhood curiosity. I was asked by the Harvard Gazette, you know, the Pravda of Harvard University, what is the one thing I would like to change about the world? And I said, I would like my colleagues to behave more like kids. Because kids have no prejudice, no baggage. They just want to learn for themselves what the world is about. And you know, that's the fun of doing science. Let's forget about showing off that we are smart and so forth. Nature may be simple. Maybe we cannot do mathematical gymnastics like string theorists do. You know, that's not the issue, not showing that you are smart. The issue is figuring out what reality is like. And if you don't have evidence to guide you, you may be completely off. You may take the wrong turn in the highway. So the search for technological signatures, which I regard as the most important question in science that the public cares about and the public funds science. So how dare the scientists ignore that question if they have the means to address it? And the search can start in our backyard. Speaking about the backyard, Oumuamua was the first object that came from outside the solar system that was identified near Earth in October 19th, 2017, by the same Pan-STARRS survey telescope that I mentioned before, that was looking for near-Earth objects. And the name means a scout or a messenger from far away in the Hawaiian language. Now, of course, based on what I said before, astronomers assume that it must be a comet, because if it's ripped apart from the outer parts of Oort clouds, where objects are loosely bound, it should probably be a comet. And here in this image, you can see this object circled in blue, and next to it, you can see streaks of dots. These are background stars that are moving relative to the object. So when you focus on the object, you see the stars as a sequence of dots representing the snapshots as they move across the sky relative to the object, or as the object moves relative to them. And this is how the object moved on the sky. It actually started in the upper right corner. Now, if there are any amateur astronomers in the audience, they would recognize the purple words next to where Oumuamua started. It says solar apex. That is the direction that the sun is moving in the so-called local standard of rest. The local standard of rest is the frame of reference that you get to when you average over the motions of all the stars in the neighborhood of the sun. So it's sort of like the galactic parking lot. It's the place that you can define the rest frame of the galaxy in our neighborhood relative to. And it turns out that Oumuamua was at rest in that frame. Only 1 in 500 stars is so much at rest in that frame as Oumuamua was. And that's surprising, because if you take a comet, an icy rock, from the outer part of the Oort cloud around the star, the relative motion of that object relative to the star is very small. It's tiny. So when that object gets ripped apart from its host star, it inherits the motion of the star. So you would expect Oumuamua to move relative to the local standard of rest, just like all the stars do. But it turns out that it was at rest there. The chance of that happening, 1 in 500. And the motion of the sun relative to this object was simply reflecting the motion of the sun relative to the local standard of rest. Sort of like a buoy sitting on the surface of the ocean at rest, and then the solar system bumped into it like a giant ship. And here is the trajectory. The sun deflected, gave a kick to this object in a different direction, based on its gravitational influence. Now, another peculiar fact of this object was that as it was tumbling over 8 hours period, its brightness changed by a factor of 10. And the brightness reflects the area that the object occupies on the sky. And so just think about a razor-thin piece of paper tumbling in the wind. The chance of you seeing it edge on is very small. And a factor of 10 change in the area that you see is a lot. We haven't seen that for objects within the solar system. And in fact, with my student, we showed that if you include data from much later on about Oumuamua, the factor is actually more like 30 than it is 10. Now that means that the object projected on the sky is at least 10 times longer than it is wide. But an attempt to fit the light curve implied that at the 90% confidence level, the object is pancake-shaped, flat, disc-shaped, not cigar-shaped, the way it was depicted in some cartoons. On the sky, it looks elongated like a cigar, but intrinsically, it's most likely pancake-shaped. And this is a dated trajectory that the object went through. In July, it started in the upper right in July. And by the way, I visited Mount Haleakala in Hawaii. I gave a colloquium at the observatory, and the director of the observatory took me for a visit. And I saw the Pan-STARRS telescope and the solar telescope that was just under construction back then. In July 2017, we were on vacation in Maui with my family. But at that time, we didn't know about Oumuamua. That's too bad, because it was approaching us. We could have easily sent a mission with a camera that would intersect its orbit and would take a close-up photo. I should say, it's often said that a picture is worth 1,000 words. In this case, a picture would be worth 66,000 words, the number of words in my book. I wouldn't need to write the book if I had a picture. And a picture can demonstrate clearly if an object is artificial or natural. And so by the time this object was identified, it was already beyond closest approach and to the sun. And it was October 19th. And as you can see, it already started to recede away from us, sort of like a guest that came for dinner. And by the time you realize that the guest is interesting, the guest is already out of the front door into the dark street. And we couldn't really chase it because it was moving faster than our rockets. And by now it's 1,000,000 times fainter than it was close to the sun, so we can't even see it. There is no point in chasing it because you need to equip a spacecraft. Even if it were moving very fast, you need to equip it with a large telescope to find the object. Objects like that get dimmer inversely with distance to the 4th powers from the sun. So it's really very dim. But you know, when I go to the kitchen and I find an ant on the cabinet, I get alarmed because that tells me there are many more ants out there. And so you can do statistics and estimate, you know, that if we found this object over a few years timescale with the Pan-STARRS survey, we should find another one with the Pan-STARRS survey within a few years after that. And in fact, the Vera Rubin Observatory, that is much more sensitive, could find one such object every month. And so what we need to do is identify those objects that look as weird as Oumuamua was, and make sure that there is a camera close to their path. One way to do that is deploying cameras throughout the orbit of the Earth around the sun in advance, and one of them will be close enough to the future interstellar objects that look weird. And then we take a photograph. Very simple. We don't need to obsess with Oumuamua. We can find others that look the same, because I believe in the Copernican principle. We don't live at a privileged time. So we looked for a few years. We look for a few more years and we'll find another one. What's the big deal? There is very little chance that we just found the only one. There should be one such object per volume associated with the orbit of the Earth around the sun. Lots of them, about 10 to the power 15, just within the solar system right now. So this object looked very weird. Let me explain. First of all, as I mentioned, the abundance is much larger than we predicted in a paper written a decade earlier. The first paper to predict the existence of a population of interstellar objects based on what we know about the solar system and the mass budget of other planetary systems. In fact, Amaya Moore-Martin, after Oumuamua was discovered, repeated the calculation in at least 2 papers where she showed there is a puzzle here. If it were a rock, you wouldn't expect so many rocks to be of the size of Oumuamua. It's just too many, too much mass per planetary system. Doesn't add up to what we need to explain Oumuamua. So that was a surprise by itself, the mere detection of this object. And then it originated from the local standard of rest, a chance of 1 in 500. And then its brightness changed by a factor of 10, implying a very extreme shape, most likely pancake-like. You know, we don't often see pancake-like rocks, but maybe, it's possible. There was no heat detected from it by the Spitzer Space Telescope, no infrared emission. Now we know what temperature the object had because as it got close to the sun, we know from its orbit what the surface temperature should be. The surface temperature of any object without an atmosphere is dictated just by its distance from the sun. And we knew the trajectory, so we knew exactly what temperature the surface should have had. Given that temperature, and given that the Spitzer Space Telescope didn't see any infrared radiation, we can get an upper limit on the size. And that was roughly the size of a football field, a few hundred feet, or 100 to 200 meters. And that's the maximum size because Spitzer didn't see any infrared radiation. Of course, it could be smaller. If it were 20 meters in size, then it must have been a perfect mirror because we know how much sunlight we received reflected from its surface. So, overall, it's pretty shiny, at the shiny end of the distribution of rocks. And the most important anomaly, it deviated from a Keplerian orbit, from an orbit shaped just by the sun's gravity. And if it were a comet, We didn't see, by the way, any cometary tail, no carbon-based molecules with the Spitzer Space Telescope down to a very tight limit. If it were a comet, you needed to evaporate about 10% of the mass of the comet in order to get the push that was detected. So 10% is a lot of mass. We would see that cometary tail very easily. But yet we didn't. Not only visually, but the Spitzer Space Telescope had a very tight limit on carbon-based molecules or dust. And the only alternative that I could think of at that time for outgassing as the source of the push by the rocket effect was the push by reflection of sunlight. But that requires the object to be very thin, sort of like a light sail. But nature doesn't make light sails. So that led me to propose maybe it's an artificially made object. Maybe it's not a rock. You know, if you show a cell phone to a caveman, the caveman would conclude that it must be a shiny rock. The mainstream proposals as an alternative to an artificial origin were as follows. I should say the scientific community was divided into three parts. There is one part which is very vocal. These are the people that write blogs, that write popular science books. But if you check each of them, you will find out, even though they're well known to the public, I will not mention names, if you check out the archive, you will find that they have never written a scientific paper over the past decade. So they are not scientists. They call themselves scientists, but they haven't written a single scientific paper, let alone about Oumuamua, but just in general, no scientific paper over a decade. They're not practitioners of science. They're not scientists. I don't even read what they're writing. It's completely irrelevant as far as I'm concerned. But I do pay attention to my colleagues that are practicing science. And the bulk of the scientific community is just not familiar with the details, doesn't pay attention to the anomalies, and says, yeah, I don't want to get into a controversial debate. It's probably just natural, business as usual. But then there is a group of scientists that I highly respect. Those are the scientists that pay attention to the anomalies. So I don't care about general statements being made on Twitter saying, oh yeah, it's natural. No, I don't care about those. I want whoever wants to propose an explanation to this object has to come up with a good explanation to all these anomalies. And that could be written in the form of a scientific paper. So I pay attention to the scientific papers of people that took seriously the anomalies and try to explain them from a natural origin. These are the people that follow the scientific practice. All the other people that shout from the sidelines are not following the scientific process. So what did these serious people, serious scientists, propose as an alternative to an artificial origin? One suggestion was that it's like a dust bunny, the kind that you find at home, a collection of dust particles bound together very loosely in a porous object that is 100 times less dense than air. Just think about it, steam coming off a boiling pot of water. So think about an object that is 100 times less dense than a cloud of steam, 100 times on average. And it's sufficiently rarefied so that the reflection of sunlight by such a dust cloud would push it enough to explain the excess push of Oumuamua. I find that to be not very plausible because the object, Oumuamua, got so close to the sun, it was heated by hundreds of degrees Kelvin. So how can such a loosely bound dust bunny maintain its material strength to hold together and spin over 8 hours when it gets heated by hundreds of degrees, and also through its interstellar journey of millions of years? Then there was this suggestion that oh, maybe the Oumuamua is a fragment from the tidal disruption of a bigger object that passed close to a star. The problem is that tidal disruption often results in cigar-shaped relics. And this object was, at the 90% confidence, pancake-shaped. You don't get that from tidal disruption. And moreover, the chance of an object getting tidally disrupted by a star, they need to pass really close to a star. The chance is small, so most of the objects you'll find, let alone the first object that you find in the interstellar space, would have never passed close to a star. And then there was the suggestion, maybe it's a molecular hydrogen iceberg, a chunk of frozen hydrogen, the size of a football field. We've never seen frozen hydrogen in space. And in a follow-up paper, we showed that such an object would not survive the journey. So the idea was that if you have a chunk of frozen hydrogen, when the hydrogen evaporates, you get a cometary tail, and that pushes the object, and you can't see the hydrogen because it's transparent, so everything is fine. That's why the Spitzer Space Telescope didn't detect anything. But the problem is that hydrogen can be easily evaporated. And we wrote a follow-up paper with Tim Huang showing that it would not survive the journey, let alone be produced in a molecular cloud. That's also very difficult. So the authors of that proposal did not have anything to say. I mean, the paper was accepted. These are the suggestions made in the literature. And I put them on the table. And of course, you know, it's possible that there is something that we haven't imagined. But my point is simple. Let's collect as much evidence as possible in the future on another object with these weird properties, because no matter what, whether it's artificial or natural, we will learn something new. Rather than saying, it's never aliens, we don't care about it, it's probably a rock. You know, just like this group of people that went to publish a paper in Nature, that reminded me of what happened in the 1930s, where there was a group of tens of scientists, tens of physicists that wrote a book, co-authored a book, arguing that Einstein's theory of relativity must be wrong. And when Einstein was asked about it, he said, why do you need a group of tens of physicists to make that point? It's enough to have one that has a good argument. So using authority, a herd, to establish the truth is the wrong approach. Each of these authors of that paper should write a paper explaining the specific anomalies from a natural origin. And this is an excerpt from one of the earlier reviews of my book on Goodreads. I didn't understand a couple of words in this, but my daughters explained it to me. I should say that this morning I checked Amazon and its editor's pick for the #1 bestseller or book in nonfiction on Amazon, #1 in nonfiction. So my suggestion is, you know, the fundamental question, is it natural or artificial? And my suggestion is that it's probably just like a plastic bottle on the beach. Most of the time you see rocks or seashells, but every now and then you find a plastic bottle that indicates that a civilization may be around. And it turns out there was another object just a few months ago that was discovered that shows an excess push as a result of reflecting sunlight with no cometary tail. It was given the name 2020 SO by the Minor Planet Center at Harvard, because it was thought to be an object within the solar system, a natural object. And then the astronomers figured out that if you extrapolate the orbit back in time, and by the way, this object was also found by Pan-STARRS. This is the orbit that it exhibited around the Earth. So if you extrapolate it back in time, the object came from Earth. It was a rocket booster that was launched into space as a part of the Lunar Lander Surveyor 2 mission. And the only reason it showed an excess push was it was hollow and thin. obviously no cometary tail, clearly artificially made. We made it. The only question is who made Oumuamua. To me, this illustrated that in principle, you don't need a light sail. It's enough to have a lightweight object, an object that has a lot of area for its weight. So you need the walls of the object to be thin. It could be a surface layer that was ripped apart from a spaceship or something else. But the point is, we can tell the difference based on this example between a rock and an artificial object that is very thin. So that was interesting. This evidence came about only over the past few months. And you can check it out. It's called 2020 SO. Now, there was a second interstellar object called Borisov after the Gennady Borisov, the Russian amateur astronomer that discovered it on August 30th, 2019. This one looked just like a comet. So I was asked, well, this one looks natural. Doesn't it convince you that Oumuamua was natural? To which I said, if you find a plastic bottle on the beach and afterwards you find a lot of rocks, it doesn't change the nature of the plastic bottle to a rock. Or another way to put it, when I met my wife, she looked special to me. And I met a lot of people since then, and she still looks special to me. In fact, you can turn the argument and say, okay, Borisov looks natural. That's what makes Oumuamua quite strange. And so the fundamental question is whether Oumuamua is artificial or natural. And I argue that the verdict should come from more evidence, taking a photograph of the next object that looks weird. If we listen to my colleagues, we would forget about it. We would just say, it must be natural, forget about it, business as usual. We will not put any funds towards putting cameras that will take a photograph of it. And of course, then we will maintain our ignorance, just like the philosophers during the days of Galileo. Why would we do that if the public is so excited? You know, there was an extraordinary amount of attention to my book. And the reason is that I'm the only person trying to advocate that, and my colleagues do not get the point. They're not willing to admit that this object is unusual, even though the people that looked at the anomalies argue that even if it's natural, it's something that we have never seen before. So my point is, if it's nothing that we have seen before, why not put all possibilities on the table and get more evidence of objects that look as weird as this one? This is the scientific process. That's the way we learn. We should not stick to our prejudice. And if you consider our technological civilization, starting from the Big Bang, so this is the timeline of the history of the universe, our technological civilization existed just for a century or so, which is 1 part in 100 million of the age of the universe since the Big Bang. It's really tiny. Most stars formed before the sun, and so they left relics in space. They may not be around. Most of them are dead by now, just like the Mayan culture. We should not try to establish radio communication with them. That doesn't make a lot of sense. I mean, only a small fraction may be around transmitting radio signals to us right now. What we should look for are relics, space archaeology. And of course, the type of planets that may host civilizations depend on the star that they reside next to, in particular the surface temperature of the star and how much light it emits. And there are all kinds of technological signatures you can look for aside from radio signals. You can look for industrial pollution in the atmospheres of planets around other stars. And here I should say the mainstream community of astronomy is advocating for these observatories that will cost billions of dollars and could inform us whether some atmospheres may have oxygen or methane in them. Now, keep in mind that the Earth, for 2 billion years, didn't have oxygen, even though it had primitive life on its surface. So if you don't find oxygen, it doesn't tell you that life is not there. Earth is the place where we find life, but there wasn't oxygen for the first half of its lifetime. Half is a big fraction. Now, if you do find oxygen, it might not indicate life because you can make oxygen by natural processes. So you invest those billions of dollars, and at the end of the day, people will argue about what it means. However, how can we get a conclusive answer? Suppose you find CFC molecules with the same instruments. These are the molecules of industrial pollution that we produce, that our industries produce, that cooling, refrigerating systems produce. Nature does not produce them. If we find evidence, spectroscopic evidence for those molecules, then there would be no doubt that life is out there. So why would the mainstream scientific community not even mention that as a rationale for investing billions of dollars? Why would it stick to just oxygen and methane? I mean, it doesn't cost more money. It's just a change in the way of thinking about the problem. And other technological signatures could be, for example, photovoltaic cells on the day side of a planet that have a special reflectance that you can look for. There should be a spectral edge different from the spectral edge you expect for vegetation, like the red edge. You could look for artificial lights on the night side of a planet, like Proxima b, if electricity is being produced by photovoltaic cells and transferred to the night side. So what you would see is, as the planet moves around, it doesn't change the amount of light that we get from it in the way that we expect, because there are some artificial lights on the night side. You could also look for beams of light that are used, for example, to propel light sails. And they leak around the light sail, so we can see them as they move across our sky as a flash of light, as a burst of radiation. Maybe some fast radio bursts are like that. You can look for a swarm of satellites around the planet as it transits the host star. You can look for megastructures, big structures like Dyson spheres. An interesting point is that to get to a fraction of the speed of light, you don't need a laser beam. You can just park light sails around the star that is about to explode. And then, just like surfers on the beaches of Hawaii, they wait for a giant wave. Here you can wait for a wave of light or a flash of light and surf on it with the light sails. And if you park those light sails before the explosion at a distance of 100 times the Earth-Sun separation, I showed in a scientific American article and also in a scientific paper that you can get close to the speed of light. So you park those light sails waiting for the star to explode and produce this flash of light, and then you get these light sails to fill up the galaxy at a fraction of the speed of light, just like dandelion seeds in the wind. Now, Fermi, Enrico Fermi, the famous physicist, at lunch about 70 years ago in Los Alamos, said, okay, well, it's possible there are intelligent civilizations out there. Where is everybody if they are? Now, to me, it sounds very arrogant. This question is really arrogant because it reminds me, when I dated my wife, she had a lot of friends, and they used to think that Prince Charming on a white horse will show up and make them a marriage proposal. But that never happened. And why should we expect that we are so special that someone would pay attention to us and visit us. We might be as common as ants are on a sidewalk. When you walk down the street, you don't pay special tribute to every ant that you see. Moreover, many of these technological civilizations may be short-lived. So we have a narrow window of opportunity. And another possibility that I thought about during the pandemic is that you may have social distancing on a cosmic scale. So a civilization that is very advanced is not really interested in establishing communication or contact because they have everything they need. They build a cocoon around themselves. They don't want to interact with lower level civilizations because that would lower their quality of living. That doesn't mean that we will not be able to find out about them because, they must, according to the second law of thermodynamics, they must deposit some trash. And just like those investigative journalists that go into the trash cans of celebrities in Hollywood in order to find out about their private lives, we can look into the trash that they throw in space and learn about them. So the most plausible explanation to Fermi's paradox is that most of them are dead because of self-inflicted wounds. But again, if we do space archaeology, we can find them. So we can look for all these things, relics. And my hope is that if we find relics of a civilization that perished as a result of a climate change or a war, that would inspire us to get our act together and avoid a similar fate. I was asked by a journalist, actually several of them, why am I optimistic that humans will come together when faced with the existence of another species out there? Well, I said because, I'm not happy about the current situation, and, unless I have a utopian view for the future, I cannot expect the future to be better than the past. And I'm just trying to be an optimist. It's possible that it would lead to turmoil in society, but I'm really hopeful that all humans will come together because we all share the same fate here on Earth. And on February 18th, within a week or so, the Perseverance rover is expected to land on Mars. And we look for signs of primitive life, either on early Mars, or perhaps even today. We will see. I'm very excited to see what it finds. The search is going on. Thank you for your attention. Okay, so you want to read the questions, or should I start to answer some?
I will. So let me start. We will start with the panelists first, and then we will move to the Q&A and then back and forth. But okay. I will take the privilege of being the host of asking the first question to you.
Okay, go ahead.
So you're involved in the Starshot initiative, right? You are in your book and in your talk. You were always saying, let's wait for the next Oumuamua, right? You have the technology in front of you. You're developing this to fly the Starship or Starship to Proxima Centauri. So when will you put, as you say, skin in the game?
Well,
why not chase the Oumuamua with a Starship now?
Oh, because we don't have that available yet. And I'm not obsessed about Oumuamua. I think there would be many more examples of its class of objects. So we should just wait for the next one to come close by. And as I said, to find it right now is very difficult because it's 1,000,000 times fainter. But, with the Vera Rubin Observatory, we might find one every month. So let's just look for more of the same. I think that is the best approach forward. And I'm putting skin in the game. I would like to know the nature of these weird objects by finding more evidence about them. That's exactly what I'm advocating. I'm advocating against ignoring them by saying we know it's never aliens. That's what many of my colleagues say. It's never aliens. Give me extraordinary evidence before I even put it on the table for a discussion. And my point is, that's unfair, because look at what is going on with the search for dark matter. The point is we should search irrespective of whether we have extraordinary evidence or not.
I agree with that. However, let's say, the LSST after, I don't know, let's say N years, does not find another Oumuamua.
Well, then we are in trouble, but I don't think it will be the case. Because of the Copernican principle that says that we don't live at a privileged time, so if we looked for a few years, found one, even with Pan-STARRS, we should find one within the 3 years later. And with the Vera Rubin, once every month or so, so it should be really something that we can look into. It cannot be extremely rare unless we happen, by chance to be very lucky, but I don't believe in luck, Or another way to put it, statistically speaking, it's unlikely that it was the only object.
Okay, let's leave it at that. All right, so let's go to Sarah.
Hi, Avi. Hello.
Hi.
I want you to know I love how you said that let us put all possibilities on the table. And that's the message I've got from, reading your interviews, listening to your podcast. And I also like how you said, let's get a spacecraft ready. Let's have some out there. So the next time one comes by, the verdict can be decided by data. Exactly. That's the main message I get from you. So I'm going to take this question from Marty Cole and change it slightly. And I just want you to know Marty Cole asked the question with both a little alien emoticon and with a heart. So it's meant in a good way. And the question is, do you personally believe that Oumuamua is an alien object, an alien artifact? Or are you just trying to get the point across that we have to put all possibilities on the table? That's the question.
That's an excellent question. I would first say that I use Oumuamua, as you can tell from my book, as an anchor to demonstrate that the current scientific culture is completely misguided, because it's very much about getting honors and awards and about showing that you are smart rather than describing nature. That's a fundamental flaw in the current scientific culture. And I was asked by the BBC yesterday, how do I envision a change in this culture? And I said, this culture did not come by chance. There are people that are benefiting from it, the people that constructed it, just like Marie Antoinette during the French Revolution. You won't expect Marie Antoinette to understand what the public is asking. She said, oh, they can have cakes if they don't have bread. So I have my trust in the younger generation that will read my book. It's really a call for action and will change the current culture. If the younger people that have no prejudice recognize that science can be exciting, because the older people make science boring. Science can be exciting. Let's find out. Let's collect the evidence. Why make it boring? Why always, have these decisions by committees, by authority? Why put together a bunch of 30 people to say, no, it must be natural? Why do that? Let's collect the evidence. Let's have the thrill of finding something new, just like kids do. And it's not about honors. It's not about showing that we are smart. By the way, you don't need mathematics of string theory to do something really fundamental.
Right, and I think I've received that message everywhere. Yeah. And so I was using Marty's question to partly deconstruct why people are saying that you're claiming it's an object, an alien artifact. So I just want to know if you could say like yes or no.
Okay, so I would say that based on the possibilities on the table right now, it's a likely option. But I don't know for sure, of course.
Right. Okay. I just wanted to hear you say that, because I've heard you misrepresented over and over, and I just wanted you to say that out loud.
No. By the way, let me explain, Sarah. I approached this subject. I worked on the search for life just over the past 5 years intensively. I remember Jill Tarter, who is in the audience here. She visited us about 12 years ago and gave a colloquium at Harvard and said, after my first paper on SETI, she said, even Avi Loeb is interested in this subject. So obviously, I didn't have a record of being interested in this subject. And the only reason I was intrigued is because I wrote the paper on interstellar objects a decade earlier, and there it was, the first interstellar object. We didn't expect it. And then I followed the evidence, and I treated this just like I treat like an anomaly in cosmology. I applied exactly the same approach. I put suggestions on the table to explain it. And somehow in this case, I realized the culture is completely screwed up, I must say. And it shouldn't be that way because the public is so excited. So I see it as an opportunity to maybe change the culture. It's really time for the astronomy community, the mainstream, to recognize that the idea that we are not alone and that we are not the smartest kid on the block is not peripheral. It should be the mainstream idea, and we should search, just like we search for the axion, just like we search for weakly interacting massive particles. In fact, more so, because so far the axion was not found. So far, WIMPs were not found. And rather than invest hundreds of millions of dollars within the mainstream on things that we haven't seen yet, not to speak about the culture of string theory and extra dimensions that has no chance of being tested experimentally within our lifetime. And that is, a culture that gets a lot of recognition as if they are carrying the torch of physics forward. What kind of a torch is it? It's not even physics. Now, there are philosophers that say, we had it since I'm the founding director of the Black Hole Initiative. In the first annual conference of the Black Hole Initiative, there was a philosopher who said, if a group of physicists agrees on something for a decade, it must be true. And I raised my hand. I said, how can you say that? Physics is about describing nature based on evidence. It's about a dialogue with nature. Very often our imagination is limited. We have to look at evidence. We can't just make a monologue and convince ourselves that we are smart. We don't need the mathematical gymnastics of string theory to recognize something fundamental about nature. And it's not about us, it's about nature. That's what physics is about. So there is a betrayal, in my view, of our obligation as physicists. It's as if a group of people that were supposed to be shoemakers decided to bake cakes. Fine, they can bake cakes, I don't care about it, but they shouldn't call themselves shoemakers if they bake cakes. So if you do mathematics without putting any skin to the game, that's not physics.
Okay, thanks, Avi. It's time for more questions, so I'm going to turn it back to our host.
Let's go to John next.
Hi, Avi. Can you hear me?
Yes, I can hear you.
Okay. So I was intrigued by the suggestion of your idea that because the Oumuamua seem to be at rest in the local standard of rest, that kind of suggested it was of artificial origin, kind of like a buoy, I think you said, kind of bobbing up and down in the ocean, waiting for these stars to sail by. So that's intriguing because it suggests that it's not a piece of alien space junk, because then it would have the velocity of that star, and it's not specifically targeted at our solar system. So I think from that you could probably make an estimate if by chance we just happen to sail by one of these buoys, you could probably make an estimate of how many intelligent civilizations there must be in the galaxy. So first, I'm interested, have you done that? And
yes.
Second, okay, and second, then I guess as a solar sail, it would have to have been launched to reach this local standard of rest. And if that's the case, would you expect it to have that 8-hour rotational period, or is there?
Well, that's a good. These are excellent questions. So you need about a quadrillion, 10 to the power 15 objects per star, quite a lot. But if you assume that there are rocks, I mean, it's independent of whether there are rocks or artificial. Okay, you need a quadrillion to explain the detection of Oumuamua within a few years by pan-stars, because pan-stars had a certain sensitivity to objects of this size, and you can estimate how many should exist if they move on random trajectories relative to the sun. And it's a quadrillion, 10 to the 15. Now, if you were to make them very thin, you need roughly the mass of an asteroid with a radius of 1 kilometer. Okay, that's not a lot. But if you make them rocks that are filled, then you need more than an Earth mass of material to be ejected per star. That's a lot. That's more than you expect. So coming back to your point about the LSR is interesting because you can ask what purpose would it serve? And I can think of two. One is you have an array, a grid of such buoys, sitting out there for navigation purposes. You want to know your coordinates relative to the galactic frame, so you do it relative to those. A second possibility is that these are relay stations that you transmit signals across the galaxy this way. But it's hard to tell, you have to figure out. And the tumbling motion is obviously indicating that such an object is not in control of its motion, right? So now this may not be surprising if most of the debris we find in space is billions of years old, because that's the age difference between the sun and most of the stars like the sun. So you would expect most of the debris to be billions of years old. And if you just look at Voyager 1, Voyager 2, New Horizons that we are launching out of the solar system into the Milky Way, after a billion years, they would not be operational. So I really don't know. I mean, I don't have a good answer to you, but I would expect any relic in space to be billions of years old. Most of them. There would be some young ones, and then the exact purpose is for us to find out. The best way to find out is get as much data as possible, put our hands around such an object. We can do that by landing, if we see that it's artificial, by landing on it. But another possibility is, if you see an interstellar meteor, meaning that you measure the velocity of a meteor, the initial velocity, and you infer that it came from outside the solar system, and then it's bigger than the size of a person, and the relic lands on the ground, then you can put your hands around it. Also, if you find a relic on the moon, the moon is a museum because it collected everything. There is no geological activity and no atmosphere to burn things up. And so if we establish a sustainable base on the moon, one way to use it is to search around for some technological debris that intercepted the surface of the moon, and we can look for it.
Okay, thank you.
Let's get to Felipe next.
Maybe if I am mute, you can hear what I say.
Yeah, we can hear you.
Thanks for a very provocative talk. It was very interesting. And actually, I was about to ask something similar to John, but I'm going to change a bit my question. But before that, a comment. About 30 years ago, we were really, uncomfortable saying that, were there other planets around other stars? And we guessed that there should be many, but we couldn't say, for sure. So we didn't have the evidence. Now we know that's, plenty. I think we are at the same stage now with probably life on the galaxy. We suspect, it would be extremely rare that there's no life outside. So that's, for the audience to make that point, I guess. But we cannot say whether it's intelligent life outside or not. And just to John's, extending John's question, let's assume, this Oumuamua, it's sort of like a starship or something, that is using gravity as, propellant, like we use in our solar system. So, as you said at the beginning, let's use a ship, and we want to know in 20 years if we can make it to the near planet, actually. So what would be, this Oumuamua? How long is it going to take for the next star? Have you computed that? And that would be more or less 10%, 20% of the lifetime of that species.
Right. So to traverse the Oort cloud, Oumuamua needed more than 10,000 years. And just think about it, it's probably not spying on us, because where were we 10,000 years ago? We weren't that interesting, right? And I should say that objects moving much faster, like the Starshot probes that move at a fraction of the speed of light, astronomers will dismiss them. They would not even consider them as objects because they move so fast across the frame that they may think, oh, it's an artifact. Astronomers are looking for things moving roughly like the asteroids or the comets, tens of kilometers per second. If something moves 1,000 times faster, they would ignore it, too fast. And also small objects like a few meters in size, they don't reflect enough sunlight for us to notice. So there may be a lot of things flying through the solar system that we don't know about. That's why we should continue the search. And we should search for things big and small, moving at different speeds. I think it's a new frontier. So I think, and in my book, I talk about Oumuamua's wager, which is similar to the wager of Blaise Pascal. That argue that, there are two possibilities: God may exist or not exist. And he said, if God exists, the implications are huge. Therefore, let's discuss it. So my point is, if Oumuamua is a technological relic, the implications are huge. We cannot ignore it.
Thanks.
All right, Jill next.
So Avi, I get a little bit pissed off when you throw the entire scientific culture under the bus, because some of us have been thinking about and building instruments to find anomalies for a very long time. And I think that when we say that if we ever are going to announce such a detection, that we require extraordinary evidence, we're doing that as a way of differentiating ourselves from the pseudoscience that is so much a part of popular culture with UFOs and all kinds of claims of things that people have detected. So
Okay.
I wouldn't be so hard on the whole culture, Abby.
Well, let me explain. To your first point, I'm talking about a factor of 1,000 in funding. I'm not talking about a factor of 2 over a decade increase in funding. I'm saying there is a discrepancy by a factor of 1,000 in what needs to be the case relative to what is the case of the community that you are talking about. A factor of 1,000 is a big factor in funding. And moreover, it's even a bigger factor in bullying, because anyone that makes a suggestion in the direction of technological signature is being bullied and ridiculed. Wait a second, let me finish. Now, my second point, which is very important, is in the Dark Ages, people used to say that the human body should not be dissected. There shouldn't be operations because it has magical powers, because there is a soul. Now think about it. If scientists were to say, we don't want to discuss the human body until there are extraordinary evidence for something, we don't want to discuss it because of all this nonsense being said about the human body, where would modern medicine be? I say, science has an obligation to focus on problems that are of interest to the public and use the scientific method to resolve them. And rather than say, we need extraordinary evidence and then step on the grass and not allow it to grow, which is currently the case. We need extraordinary evidence, but anyone that mentions this possibility is ridiculed by some blogger that doesn't even write a single paper in a decade. That makes no sense whatsoever. This blogger should first practice science.
Well, some of us do.
No, let me finish. How dare people make statements about scientists that explore these possibilities within the scientific method? That's the acidic culture that I'm talking about. There is an acidic culture that suppresses innovation in the current culture of science. And the best example is SETI, because they say we need extraordinary evidence, and then they don't let people search for that extraordinary evidence by a factor of 1,000. I'm not talking about a small group of people at Berkeley or at the SETI Institute doing some work. I'm talking about a factor of 1,000 increase in your budget, in the budget of the community, and a factor of 100 more people working on it, not at the SETI Institute, but everywhere, in every university. This becoming a mainstream subject, just like string theory is. Why should we fund searches for dark matter and not for technological civilizations as part of the mainstream? That's my argument. And I find it really surprising that I get opposition from you to that notion.
I really don't like the generalization of the whole culture being bad mouth.
Okay.
And sure, I'd love our budget to be 1,000 times.
Okay, so why are you opposing me? Why don't you join me in arguing for 1,000 times more budget?
But Avi, I've been doing that for 40 years. Right? We've been arguing.
Well, you are arguing with me about the credit of who gets credit for arguing that, rather than saying I endorse your view. Why don't you say I endorse your view instead of saying, oh, I've been doing it, why are you doing it now? Why do you say that? Why don't you join forces with me and go for it, rather than say, actually, I said it 40 years ago, you are saying it now, I want credit for that, you don't get credit. Who cares? Like, we are trying to promote a common cause, and you're arguing with me about credit. I just don't understand it.
I think the culture as a whole shouldn't be bad-mouthed. That's what I'm saying. I think that you're being too sweeping in your condemnation.
Okay, factor of 1,000 is too sweet. Okay, fine.
Okay, so let's go to the next question. Dietrich.
A quadrillion artificial objects gives me a problem. And I can believe that if Oumuamua is an artificial object, that this implies that Oumuamua has been sent to us on purpose. And that would require intelligence, first of all, to arrive here. Secondly, because it was probably based on the knowledge that there's life on Earth. But then this intelligent civilization has sent this object on a trajectory that takes 1 million years, at least. On a human scale, that would be completely stupid, not intelligent. Unless, and that is a mind-boggling thought, that 1 million years means nothing to that civilization. I have no way to fathom what that might mean. And the fourth thing that may be able to tell us something about the intelligence of that civilization is the trajectory of Oumuamua through the solar system, which in my opinion is the most stupid one could imagine. And should one not expect from a very intelligent civilization to do a better job than that?
Well, I should say that's an excellent question. And indeed, I thought about it at the beginning when I started working on this. And the only sense I could make of it, frankly, is if you wanted it to be a targeted probe, then the purpose would not be to spy on us. I mean, whoever sent it did not know about us because, as you say, it probably traveled for many millions of years through interstellar space. And, we were not that interesting so long ago. So the only sense I can make of it is just a probe that wants to get to the habitable zone of stars. Okay, just, you decide that sun-like stars could have intelligent life around them. And you want, without knowing what's there, you're sending probes to the habitable zones of stars. Okay, and so someone made the gamble of checking the sun. And now this thing came by and, did whatever it was designed to do. The problem I have with a targeted probe is that, it was tumbling, as we were discussing before, and it doesn't, it's not an indication of a controlled instrument, And by the way, just a week after it was discovered, I visited Yuri Milner, and we had a conversation to check it out and use the Breakthrough Listen radio telescopes to put an upper limit of a cell phone transmission from it. I mean, obviously that doesn't mean much because who knows whether it transmits at gigahertz frequencies in our direction, maybe it transmits sporadically. But I agree with you that we were not in mind when this thing was sent out. That's for sure. I completely agree with your question. It's a very good one.
Let's go to Giuseppe next.
Thanks, Thomas. Thanks, Javi, for the talk. I've been thinking, you said we basically ignore evidences. You made some examples, like Oumuamua is the first striking one, and then you also mentioned some pollution in the atmospheres of exoplanets we are not looking for. So have you designed some experiments, or are you thinking, or are you doing mining into archival data, looking for the evidences we have been ignoring so far, or are you just waiting for larger telescopes and more sophisticated instrumentation?
So I think, okay, if we talk about a new frontier now in astronomy, which I think it should be, searching for the nature of interstellar objects, okay? Because these are just like objects coming from the street into our backyard, and it saves us a trip. We don't need to visit other systems. We just collect, you know, information about the objects that arrive at our backyard. And I think it should be a new frontier, okay, in astronomy. What's the most effective way to isolate the plastic bottles from the rocks, okay, within that reservoir of objects? And I think that actually deploying a lot of cameras, that would not be very expensive on CubeSats. You know, they're just putting a lot of cameras within the orbit of the Earth that would monitor whatever is passing by. One of these cameras would be close to the next object. We'll just take a close-up photo. I think that's one good approach. Of course, it's easier, it's cheaper than building a big enough telescope that at the diffraction limit will be able to resolve 100 meters across a fraction of an AU. I mean, that's really very challenging. So I would advocate for putting, you know, deploying cameras as the next step on this thing. Of course, you can think about the missions, you know, like as soon as you discover something, you launch a spacecraft that will intercept its orbit. That's another approach. But I think having cameras is not a bad idea, because then you can also see smaller objects just because you happen to be nearby them, even though they reflect less sunlight. So even though you don't see them from Earth, if the camera happens to be near one of these small objects, it will see it. And also you can detect, if you have an array of cameras, you can detect very fast moving objects that move much faster than, for example, the Oort cloud objects coming close to the sun. You know, there should be halo interstellar objects that come from the halo of the Milky Way, because we have stars in the halo of the Milky Way. And so at least there should be some rocks coming from the halo, but also perhaps artificial objects. And they would move at hundreds of kilometers per second. So about a factor of 10 faster than Oumuamua. And you know, it would be good to see all sizes and all speeds. Maybe there is something moving close to the speed of light, you know, that would pass by, and that would be amazing, you know, if we see it.
So no chance to find signatures in our archival data.
The current data, I think, well, with Pan-STARRS, of course, we should continue, and then Vera Rubin. Another thing that I'm really excited about is the search for meteors, you know, interstellar meteors. And together with my student, we found one from 2015 that was reported. You know, we just looked at the catalog that was put together by the sensors that are used to detect, you know, ballistic missiles. This is classified information, but there is a CNEOS catalog. And there was one object that moved at a speed that indicates that it came from interstellar space. We identified it. The referees rejected our paper because they argued that you can't trust the government. So there were no error bars on the measurements because they are classified. I would assume that the measurements are extremely precise, because you want to know if a missile comes to Boston or New York City. And the referees of our paper said, oh, we don't trust the government unless the error bars are declassified. We won't accept the paper for publication. Fine, so it's just on the archive with Amir Siraj. We found one such object from 2015. And I think looking for interstellar meteors is very interesting, because if you're talking about a big meteor, the relic can be found on the ground somewhere or in the ocean, and then you can put your hands around it and see what it is.
Okay, let's go to Paul next.
Avi, thank you very much for that very clear talk. It's quite obviously very controversial, produces much heat and arguments. And I want to comment more than contribute on three aspects: a psychological aspect, a sociological aspect, and an epistemological aspect. So you engaged, which is quite natural in your position, to speculate about the motives of your opponents who don't accept what you are saying. So you say it's probably ignorance and it's parallel to the Galileo case. Well, first of all, the Galileo case is probably historically not correct, because the opposition to Galileo had very good arguments because they doubted the quality of the data that came through the telescope. And given some metaphysics there, that wasn't just stupidity, but that's an open question. The point is simply that I found, when I was still a physicist, I had twice during my graduate years outrageous ideas, and I thought, how is it possible that I have these ideas and not the others, but much more established physicists? And believe me, I always found a psychological explanation. So I never believe my own psychological explanations anymore why people are not persuaded of what I'm saying. So this is just very dangerous terrain. Okay, this is just in general. The second thing is the sociological dimension, which is now, I think, very important, because what you are doing, for instance, I'm not criticizing you, I'm just commenting on what's happening. When you publish your book, what you're doing is you're seeking for your opinions, which are not in the mainstream of physics, you're seeking an audience outside of the physics community. And this is something in the sociology of physicists, I don't know about biologists and chemists, but it's probably very similar, against which physicists react extremely fiercely. Because the idea is, if you want to have recognition as a physicist, the only instance that legitimately gives you recognition are the physicists themselves. It's a very closed business. It's only the physicist. And as soon as someone tries to get recognition outside of the physicists, all the physicists say, this is not okay. And this is a sign of being not serious. So it's just a very dangerous move. And you should not be surprised, given the sociology of physicists, that this alone, you may be right or wrong, it doesn't play a role. Just for the sociology, how physicists, the physics community functions, you are on a very, very dangerous terrain. So especially when you say the younger people, they should look, or when you talk about bloggers, the physics community reacts extremely sensitively towards that. That's just the description. I'm just describing what's happening.
Yeah, you can describe it, but let me reiterate that I don't care about what people say, okay? My focus is on the ball, on the evidence. And what I see is that the interpretations given to the anomalies of Oumuamua are not more compelling than an artificial origin. Given these circumstances, I follow the evidence that says we should entertain that possibility. Now, my colleagues can say whatever they want. I don't care about it. I just care about the evidence. I'm not guided by psychology. I'm not guided by sociology. And I don't care what string theorists would say, what bloggers would say. If one of these people would write a paper that explains the anomalies in a plausible way that doesn't invoke something that we have never seen before, like a hydrogen iceberg or a cloud of dust particles. If there was a paper like that, it would have been convincing. But there is no paper like that. Yeah. So you want me to shy away from making the truth known? I mean, I'm like the kid that says the emperor has no clothes. Yeah. And you are telling me you are not allowed to say the emperor has no, because people around you will get offended. I don't care about people. You have to understand, I care about evidence. We sincerely, as scientists, should be truthful. What you see from me is what you get. I'm not manipulating. By the way, let me give you an example. I was telling my publicist a week ago, he was saying, oh, you know, Avi, you did a great job marketing your book. Look at how extraordinary response we are getting. And I said, I corrected him. I said, I'm not trying to sell my book. This is not at all my interest. I'm trying to convey a message and it appeals to the public. And that's why my book sells. Then I see someone making this statement on Twitter saying, oh, he's just trying to sell his book. Now, I was telling my publicist that this is not my goal, and people just invent all kinds of incorrect notions. What I'm trying to say to you is that I'm not motivated by the criteria that you are using to judge my actions. I don't care what sociology or what psychology says. I care about the evidence. Oumuamua is a physical object that had some properties, some anomalies, and what goes in the minds of people is irrelevant. I care, I put my eyes on the ball, not the audience. You are talking about the audience. You are telling me, look at the audience, it goes up and down. You will make them angry because of this and that. I don't care about the audience. I look at the ball.
Fine.
The ball has anomalies. I want to explain them. If one of the members of the audience would explain those anomalies in a convincing way, it will change my opinion.
Sure. Yeah. No, I think you're getting me wrong. This was far from a criticism. This was just commenting for outsiders. Why is there so much heat going on? And I'm just trying to explain what was going on. And now I'm only coming to this epistemological dimension. So this is what you're interested. Of course, you're a scientist, you're not a sociologist. Of course, you're doing your stuff, bringing argument, refer to the evidence, and so on and so forth. The point is that I think that the metaphor that you see, that you use with the plastic bottle on the beach, which is of course a wonderful metaphor. But the point is, if you look at the beach and you see the plastic bottle, it's immediately clear that this is not a natural object. So what people would expect is when you say, and the title of your book is just, you know, very big mouthed, people would say, if you claim this is an object of extraterrestrial origin, what you call, which is a very good term there, the technological signature should be so incredibly obvious, right? That then only then people would get convinced.
Well,
you're absolutely right.
You're getting back to Sarah's question. That was the first question I was asked and I answered it. We don't know for sure, okay? We don't know, but we should keep this option on the table, given that the alternatives are not more plausible. That's all I said to Sarah in response. So bringing this up again, as if, and don't judge a book by its cover. By the way, the title of the book and the way the cover looks was selected by my publisher. They want to sell books, okay? I don't care about that. You should read the book and not judge it by its cover.
Look, I'm not judging it. Again, you're misunderstanding me.
No, I'm just saying in general. This is
at all. I'm just trying to explain what is going on.
You know, not judging a book by its cover is it's not about you. It's just something that is being said in general.
Yes, but I'm trying to explain what is going on. So on and the last point was simply this epistemological dimension, because relative to our current knowledge, the extraterrestrial origin is such an incredible, outstanding hypothesis that people are very reluctant even to consider it, some of these people, which is of course very, very delicate. But the point is they would expect that this technological signature is really overwhelming. And the problem is that is not yet the case.
Of course, and I admitted that to Sarah. But the point of the matter is, if you look at kids, you know, the adults are telling them this and that, and the kids just say, I want to test it for myself, you know, and that is a healthy approach because it's not based on prejudice. And I'm advocating for getting more evidence. The people that oppose me are saying, we know it's never aliens. And how dare, you know, I find that really ridiculous because of all the arguments in my talk. Anyway.
Yeah, no, I agree to that.
Yeah.
Okay, I want to take one question at least from the Q&A.
And soon I have to go because I have another commitment.
Okay, so let's do one more question. So inspired by Samuel Loeb, who's asking to push this, let's say, extraterrestrial civilization indication to the extreme and saying, well, if we find something, right, if we take a picture and indeed it's a spacecraft, what to do with it, right? So many people have warned us in the past that actually contact might be very dangerous, right? So what if it's a probe that just waits out there to be touched and it immediately starts, you know, 3D printing whatever sextuple DNA strands, right, out of whatever it touches.
Yeah.
So what is your opinion on that?
Yeah, first, you know, as a matter of general practice, when you enter a room full of strangers, you better be quiet and listen. Because you never know what the risks are. If you judge by human history, you know, when the Europeans went to the Americas, the consequences were not great, you know. So Unfortunately, we were transmitting radio signals for more than 100 years. And there is a bubble of radio waves around us announcing our existence. And if there is a civilization within that region that has radio telescopes similar to the ones we have, they already know about us. And we might hear from them, but it just takes time. Now, with respect to seeing a relic, I agree with you. One has to be cautious and so I would recommend looking at it from a distance, sort of like in the era of COVID-19, you never want to touch things. First, you want to look at them. So let's figure out what it looks like at first, and then we can send instruments that will land on it, maybe, and just like we do landing on comets or asteroids. But let's do one step at a time. First thing I want to find out is whether they're artificial or natural, because that's really the debate. And by the way, by collecting the data, even if it's natural, we already know that it will be something we have never seen before, and we will learn something new. So one way or another, I will admit I was wrong at that point if we see that it's a rock, but it will be something really unusual, and we'll find something new, I think, about planetary formation that we haven't imagined. Maybe it's a cloud of dust, and you have it as a preliminary stage in the formation of planets, and you just blow off these dust clouds into space, and that's what we saw. Maybe, and that will be very interesting if we have dust clouds floating around. I would say, okay, I was wrong, and we learned something new. So it's a learning experience, and I'm willing to be wrong, and I'm very much in favor of getting as much evidence as possible. I think the future is exciting. It's not always like the past, and that's the whole fun of doing science. The finding new things. We should embrace that rather than resist it and claim credit for something we proposed 40 years ago. Like, who cares? Let's find out what these things are. That's a sense of modesty is really in place here.
Thank you. On that note, since you don't have time anymore, let's close it out. And I completely agree with you. Let's be open-minded, but based on evidence. So thank you, Avi, for your time. Thank you for your thoughts. Thank you very much for the panelists who have contributed to this great Q&A. Thanks to the audience for sticking around. It was an extended webinar. Thanks to Patricio for translating this. Please be so kind and fill out the survey at the end of the Zoom webinar. And I would like to announce the next Golden webinar, which will be given on the 19th of February by Marcelo Gleiser, who's a professor of physics and astronomy at Dartmouth College. And he will be talking about something very related to this discussion: the island of knowledge, the limits of science, and the search for meaning. Okay, so I hope I will see many of you back here. Until then, stay safe, stay healthy, and until the next Golden webinar in astrophysics. Bye, everyone.
Bye-bye. Stay safe.
Bye.
Bye.